So now that we've talked about changing bases of exponents to match to solve these equations, let's switch gears to when you can't make that happen. Which is what example 4 is, because notice here, I have 7 to the power of 2x equals 6. Well, there's nothing I can do to change 7 into a base of 6 or 6 into a base of, it's just not going to happen. And I can't just divide by 7 because 7 is an exponent. So instead, what we can do is we can take the logarithm of both sides. So I'm going to take the logarithm of the left and right side. So the logarithm of 7 to the power of 2x equals the logarithm of 6. The reason why this helps us is because when you have exponents within a logarithmic function, you can take that exponent, remember, and kick it to the front. So really, this will simplify down into 2x times log of 7 equals the log of 6. Well, notice on the left side, I have the 2 being multiplied by the x, which is being multiplied by the log of 7. What's the inverse of multiplication? Division. So, what we do from here is I'm going to divide this left side by 2 times the log of 7, and I'm also going to divide the right side by that. Because the 2 and the log of 7 were being multiplied, so to get rid of them, to cancel them, or their inverses, would be to divide. That leaves me with just x, and on the other side, I have the log of 6 divided by 2 times the log of 7. Well, this doesn't look like a very nice answer because it's all written in terms of logarithms. So what we will actually end up doing is we will type this into a calculator, but you have to be careful and make sure that when you type it in, you wrap the entire denominator into parentheses. So I'm going to show you what this is going to look like. I'm going to make my screen a little bit bigger. All right, so, whoops, there we go. Okay, so here's our calculator. We are going to take the log of 6, close our parentheses, divided by, I'm going to start a parentheses and say 2 times the log of 7, and then I'm going to close with 2 parentheses, because what this is going to do is it's going to tell the calculator we're dividing by the product of 2 and the log of 7. If you don't include those parentheses, your calculator is not going to read it right. All right, and then I hit enter, and I get approximately 0.46 as my answer. All right. So there we would go. So example 5 is similar, so I want you to give example 5 a try and see how far you can make it. It's a very similar start as this one, and then press play to see the answer. Okay, so example 5, I told you it was a similar start, so here we go. We are going to have the log of 5 to the power of 2x plus 7 equals the log of 19. I'm going to take that exponent of 2x plus 7, and I'm going to kick it to the front. But I have it wrapped in parentheses because unlike the last one, it's not just a single term. It's a binomial 2x plus 7. I'm not going to multiply log of 5 into that parentheses. That would just get pretty messy. So instead what I'm going to do is I'm going to divide both sides right off the bat by the log of 5. And that's going to get me 2x plus 7 equals the log of 19 divided by the log of 5. You could go through and evaluate and figure out what that decimal is, or you can wait and do it at the end. You'll get maybe a slightly different number, but it'll be pretty much the same. What we're going to do from here to solve is we're going to subtract 7. So again, this log of 19 over the log of 5 technically represents a decimal number. I'm just going to leave it as it is for right now. The last thing I'm going to do to get x by itself is I'm going to divide by 2. Okay, so this is where things begin to look pretty messy. So I'm going to show you how I type this into the calculator to figure out my approximate answer. So I'll make this bigger. All right, so the first thing I'm going to do is I'm going to take the log, let's see where are we at, there we go, the log of 19 divided by the log of 5, right? Hit enter, and I get this decimal, and then I'm going to build off of that. So then I'm going to say minus 7, because what the calculator is going to do is it's going to take this previous answer and subtract 7 from it. Now I'm going to take that answer and do my last step for my work, which is divide by 2. And I get approximately negative 2.59. Now, you might have felt like you could have done it a different way and you still end up at approximately negative 2.59, and that's okay. There are a couple of different ways you might have approached this problem, but in the end, you should be getting pretty much the same decimal. Now, if you started by taking the log of 19 divided by the log of 5 and you wrote a decimal there, you might have some slight rounding error, but it should still be approximately the exact same answer as mine. All right, last example problem is example 6. This one is a little different from the rest because it already has a logarithm in it and our base is a variable. But what I want to do here is I want to remind you that logarithms, the way you solve them, is to convert it into exponential form. And I want to remind you of that with this example problem here. So I have the log base 5 of x squared equals 6. If I rewrite this in exponential form, I'm going to take the base of the logarithm. The exponent is the answer of the logarithm, which is 6. And that is going to be equal to the thing that was originally being plugged in, which is x squared. So I have 5 to the power of 6 equals x squared. 5 to the power of 6 is a really big number. It is 15,625. And how do I get rid of a power of 2? I square root it. So we get 125 is equal to x, technically plus or minus. All right. So that is the end of 4.5. I hope you had fun with this lesson. I know these problems can seem kind of challenging at first, but the more you work with them and the more you familiarize yourself with them, the easier it is going to get. But it might take a little bit of trial and error at the beginning, and that's okay. That just shows that you're learning and that you're being challenged, but that's good because your brain is growing. All right, let myself or Mr. Brasser know if you have any questions. Have a wonderful day.